Again, these nitrofurantoins are also, they are known as a urinary antiseptics. And they are actually older class of antibiotics. Those were used for the urinary antiseptics and as a GIT infections. They are used in the GIT infections and urinary infections. But nowadays, only one or two molecules are there. So, what is mechanism? They undergo enzymatic degradation or enzymatic reduction in the body, and they will produce highly reactive metabolites like nitric radicals and other radicals, so which will damage the bacterial nucleic acid, that is the DNA. Also, they have radiomimetic properties and mutagenic properties. Spectrum of activity active against the Staphylococcus aureus, Streptococci, Salmonella, Shigella. So, out of that, furazolidone that inhibit the growth of this particular microorganism known as a Trichomonas vaginalis that causes the frequently infection of female genital organ. That is a vaginalis, Trichomonas vaginalis. Okay, so that is usually drug usually the furazolidone. Now, New furoxime. It is also another nitrofuran. New furoxime is also again effective against Candida albicans. That is one of the most common cause for vaginal infection. Candida albicans. Most common cause for vaginal infection. Okay, Nufuroxime and other format. So these drugs, they are bacteriostatic in a lower concentration. As you increase the concentration of this drug, they will act as a bactericide. So lower concentration में bacteriostatic होता है, higher concentration में bactericidal होता है. So these are the older drugs. ये अभी maximum इसको use नहीं करते because you have a lot of antifungal drugs, other superior antibiotics. So that's why nitrofuran antibacterial. So they damages the DNA of bacteria by producing the radicals, intermediate, highly reactive intermediate radicals. Now adverse effect. So they causes the abdominal discomfort. Any drug, most of the drug causes abdominal discomfort like nausea, vomiting. They rarely can cause hemolytic anemia in the patient deficiency with glucose 6 phosphate dehydrogenase. And they may produce systematic lupus erythematosus like reaction, skin reaction, immunological reaction. Polyneuritis that can occur, especially patient with the impaired renal function. इसका renal function impaired है, किडनी में कोई प्रॉब्लम है, polynephritis हो जाएगा. First drug nitrofurantoin in that also. Nitrofurantoin. This is the only drug that is used urinary tract infection nowadays also. So nitrofurantoin is the only available drug. So very promising drug for your urinary tract infection. अगर आपको बहुत ही acute urinary tract infection हो गया, आप ओटी जाके ओवर द काउंटर में इसका मेडिसिन ले सकते हो, नाइट्रोफुरान. ओके, एक टैबलेट ले लिया आपने, तो विद इन हाफ एन आवर आपका कितना भी बर्निंग सेंसेशन हो आपके यूरिनरी ट्रैक्ट में, दैट विल बी रिलीव्ड. नाइट्रोफुरान. सो its kinetics. Food will increase the bioavailability. Presence of food in the stomach will increase the bioavailability of this drug. It is metabolized by nitroreductase. It is metabolized by nitroreductase to form a different radicals of superoxides, oxygen radicals, which damages the DNA of bacteria. Okay, in the very first point we have seen, they produces the reactive metabolite which can damage the bacterial nucleic acid. So what kind of reactive metabolites? Superoxides and oxygen radicals. So this particular nitrofurantoin, so they produce it is reduced inside the body by enzyme known as a nitrogen reductase. Okay? And they will produce radicals like superoxide radicals and oxygen radical, which damages the nucleic acid of bacteria. Okay, and it will kill the bacteria. Now these nitrofurantoins, all these nitrofurantoins, they are active only below pH 5.5. So they are active in the acidic pH. So okay, so nitrofurantoin जो होते हैं वो acidic pH में ही active होते हैं. अगर basic pH में अगर वो जाएंगे, so they will not have their antibacterial effect. So alkalization of urine in case of nitrofurantoin decreases the activity of drug. Okay, so इसमें अगर यूरिन का pH बढ़ाने वाले ड्रग्स देंगे, that will decrease the activity of nitrofurantoin. So they are only active against pH 5.5, below pH 5.5. Remember, this is a drug of choice. Drug of choice in case of complicated lower UTI, lower urinary tract infection. So it is a drug of choice, nitrofurantoin. So nowadays, fast dissolving tablets of nitrofurantoin is available. If you got a very bad urinary tract infection, you just have to go, a doctor will prescribe, or you can also take, because this is only urinary antiseptic, so you can also take. So this drug will relieve your UTI within a 45 minutes. कितना भी complicated urinary tract infection हो, कितना भी burning sensation हो, so while you are passing urine, you will get a very burning sensation in the urethra. That is nothing but the UTI, lower UTI. So lower urinary tract infection किसको बोलेंगे कि अगर आपके यूरेथ्रा में जब आप यूरिन पास करते हो, at the time if you are getting a burning sensation, intense burning, that means you are suffering from UTI. So for that, drug of choice is nothing but the nitrofurantoin. Now this drug will not appear in the urine if there is a severe renal failure or azotomic patient. Azotomic means if there is an absence of urine. Absence of urine, that means azotemia, azotomic patient. So if renal failure is there, then this drug will not be eliminated. This drug can color urine brown. अगर आपने ये ड्रग लिया तो आपके यूरिन का कलर ब्राउन हो सकता है. There is another drug which can cause orange coloration of urine. That is nothing but the rifampin. So rifampin is the anti-mycobacterial drug used in the tuberculosis. वो जब लेते हैं तो यूरिन आपका ऑरेंज कलर का होगा, ऑरेंज या रेड coloration of urine. That is the rifampicin. So another drug that causes the coloration of urine is nothing but the nitrofurantoin. Nitrofurantoin will color your urine brown. Remember, नहीं तो ऐसा नहीं होना चाहिए कि आपने नाइट्रोफुरान ले लिया तो मॉर्निंग में अगर आपका यूरिन ब्राउन हो गया तो आप, it can cause urine, it will not affect you. Remember drug of choice in the UTI. Next one is the furazolidone. Furazolidone. Okay, so furazolidone is nothing but the drug used for, it is used for GIT infection. So if you are suffering from any kind of diarrhea, mostly used for GIT infection like bacterial enteritis, bacillary dysentery, then giardiasis, and also used topically for treatment of trichomonal vaginitis. Trichomonas vaginalis infection is there. Trichomonal vaginitis. So it is mostly used as a antidiarrheal agent, used for the treatment of GIT infection, and topically used for the treatment of trichomonal vaginitis. So then next one is a nefuroxime. So it is a selective agent for antifungal. So it is a selective antifungal. It is a selective drug for Candida albicans. It is a common vaginal pathogen. That means most of the infection of vagina that is caused by is Candida albicans. That is this nefuroxime is a selective drug used for that Candida albicans. It is used along with the furazolidine topically also. Then nitrofurazone. So this last one is nitrofurazone used for treatment of wound and skin infection, and it may cause allergic reaction. That's it. So these are the nitrofurantoins. So nitrofurantoins में आपको बस 2-3 पॉइंट ही याद रखना है, because they are outdated drugs and only 1 or 2 drugs are used. So आजकल ये furazolidone जो है वो एक आपको देखो, आप अगर आपको if you are suffering from diarrhea and dysentery, if you go and visit a medical store, if you ask the drug, first drug that is given by the pharmacist is nothing but the furazolidone. तो आपको एक येलो कलर का टैबलेट देते हैं, येलो कलर का टैबलेट में वही होता है furazolidone for GID infection, and for UTI infection nitrofurantoin is the drug of choice. क्वेश्चन आ चुका है, drug of choice for urinary tract infection. Nitrofurantoin is a drug of choice. Not getting control from nitrofurantoin, then only they used to prescribe you this norfloxacin, that is quinolone antibiotic. तो अगर नाइट्रोफुरान से नहीं कंट्रोल हुआ तो क्विनोलोन दे दी या फिर बाहर. These are the nitrofuran antibacterial drugs. Chemistry of sulfadoxine and quinolone. So this now what we have seen, आपका जो नॉर्मल मतलब जनरल एंटीबैक्टीरियल ड्रग्स होता है, जनरल एंटीबैक्टीरियल ड्रग्स उसका जनरल कंसिडरेशन हो चुका है, उसमें क्लासिफिकेशन वगैरह सब आ गए. Then your sulfonamides, then we have seen this sulfadox. After that we have seen quinolone antibiotics. After that we have seen that quinolone antibiotics. That we have seen nitrofurans. Today nitrofurans is complete. Quinolones are complete. Now we'll see chemistry of same. Chemistry of sulfa drugs and quinolone antibiotics. First, sulfa drugs. So we have seen from the pharmacology. So what are the sulfa drugs? They will have two moieties, two structures. That is the sulfamido group, amino group. They have two structural features. Sulfamido group. SO2 NH group, that is known as sulfamido group. the nitrogen of sulfamide group is given as a number 1, and after that there is benzene, and after that para amino, that amino group is nitrogen of amino group is numbered as a 4. So if there is substitution on this sulfamide nitrogen, they are known as a N1 substituted sulfonamides. If there is substitution on this fourth, that means if there is substitution on this nitrogen from amino group, it is known as a N4 substituted sulfonamides. Right? So we'll see the classification first. So classification first is nothing but the, so depending upon their kinetics, drug which are absorbed and excreted rapidly. तो जो ड्रग जल्दी एब्सॉर्ब होंगे, जल्दी रिमूव होंगे, तो those drugs which are absorbed rapidly, eliminated rapidly. So in that case, these drugs are used for the systemic infection. जो जल्दी एब्सॉर्ब होंगे, जल्दी रिमूव भी होंगे, वो किसके लिए यूज करते हैं? सिस्टमिक. So sulfonamides will have this structure common. So the amino nitrogen present in the sulfonamide group is numbered as 1, and nitrogen present in the amino group is known as a 4th nitrogen. If there is substitution on this sulfonamide nitrogen, known as a N1 substituted sulfonamides. If there is a substitution on this nitrogen present in the amino group, known as a N4 substituted sulfonamides. Now classification we will see. So first class is nothing but the drug which are absorbed rapidly and excreted rapidly. So उसका absorption जल्दी हो जाएगा, उसका elimination भी जल्दी हो जाएगा. So mostly they are used for the systemic infection, known as a systemic sulfonamides. For example, sulfamethoxazole, okay, then sulfuxazole, then sulfapyridine, sulfadiazine. They are used for systemic infection. So they are used for systemic infection. Orally ले सकते हो उसको. They are not used topically. They are used for systemic infection. Now those drugs which are poorly absorbed from GIT, वो ड्रग जो GIT से बहुत ही कम मात्रा में absorb हो गई या फिर नहीं भी होगी, and that's why they are used for the, that's why they are used for, they are used as a, they are used for the local antiseptic or local antibacterial drug for GIT infection. Drug which are poorly absorbed from GIT, they will act locally. Okay, they are also known as locally acting drug on GIT. Example is sulfasalazine and thallyl sulfathiazole, succinyl sulfathiazole. So thallyl sulfathiazole, succinyl sulfathiazole, sulfasalazine, all these three are the prodrug. Thallyl sulfathiazole, succinyl sulfathiazole, and sulfasalazine. These three are the prodrugs. So those drugs which are used for GIT infection locally. क्या है कि जब आपको इन ड्रग को ले लेंगे, GIT में जाएगा, ये वहाँ पे वो ब्रेकडाउन हो जाएगा, ब्रेकडाउन हो जाएंगे, वहाँ से एब्सॉर्ब नहीं होंगे. So they are poorly absorbed from GIT. They are known as local GIT antibacterial drug. Okay, sulfa drug used for locally GIT infection. So that is sulfuxazole, then sulfapyridine. So, okay, so there is nothing but the sulfasalazine, thallyl sulfathiazole, and succinyl sulfathiazole. These three drugs: sulfasalazine, thallyl sulfathiazole, and succinyl sulfathiazole. So all these three drugs are nothing but the, they are a prodrugs. तो drugs use करते हैं GIT में system locally infection के लिए. They are not absorbed systemically. ये स्टमक में जाएंगे, वहाँ पे ब्रेक होंगे, रिलीज करेंगे ड्रग, वो लोकली ही इंटेस्टाइन में एक्शन दिखाएंगे. So locally they will show their action. They will not get absorbed into systemic circulation. That's why they are poorly absorbed from GIT. Sulfasalazine, thallyl sulfathiazole, and there is one more, succinyl sulfathiazole. So all these three are the prodrugs. Then drug used topically for topical infection. Okay. So for example, for ocular infection, infection in the conjunctival sac of your eyes. तो आई इन्फेक्शन के लिए एक सल्फासिटामाइड नाम का एक ड्रग है. सो ड्रग यूज्ड टॉपिकली इन द कंजक्टिवल सैक आफ्टर ऑक्यूलर इन्फेक्शन और टॉपिकली फॉर वजाइनल इन्फेक्शन. मेफेनाइड, सोडियम सल्फासिटामाइड एंड sulfadiazine. So out of that, this sulfasitamide is ocular antibacterial drug. Sulfasitamide is used for conjunctivitis. Conjunctivitis means eyes infection. Silver sulfadiazine is used for the burns topically. Cyanide is used for the vaginal infection. Now, depending on the chemical class, chemistry, sulfa drugs are like N4 substituted sulfonamides. N4 substituted sulfonamides. तो N4 कहाँ पे है ये? तो यहाँ पे substitution रहेगा उसका. So like this prontosil and solocoptine. Prontosil and Sulfocopticil. These are the N4 substituted sulfonamides. Classification के ऊपर क्वेश्चन आता है इसके. N1 substituted. So N1 means substitution will be at this. Substitution will be N1 substituted. So N1 substituted is nothing but the sulfadiazine, sulfacetamide, sulfadimidine, and there are another category known as N1 as well as N4 तीसरा category. Both N1 as well as N4 substituted sulfonamides. मतलब ये इनमें क्या होगा, दोनों भी साइड के ऊपर सब्स्टिट्यूशन. तो सक्सिनिल सल्फाथायाजोल, डालिल सल्फाथायाजोल, सक्सिनिल सल्फाथायाजोल, डालिल सल्फाथायाजोल, both are nothing but the prodrugs. दोनों भी क्या है, prodrug है. Depending upon the chemical chemistry, they are classified into 3, N1, N4, and both N1 and N4. There is one more known as a non-anilino sulfonamide. Non-anilino sulfonamide. ये anilino क्या होता है? Anilino means what? Benzene ring plus NH2. Benzene ring plus NH2. So you can say this is aniline structure. So it is aniline. So non-anilino मतलब क्या? यहाँ पे अमाइनो ग्रुप नहीं रहेगा. So non-anilino means so there will not be aniline in the structure. So for example, non-anilino, that is a mepanide. That's why this mepanide is a sometimes known as non-sulfonamide. Because sulfonamide का structure में क्या होता है, ये दोनों रहेगा. It is a common structure for sulfonamide. Now in the mepanide, this aniline will not be there. Benzene will be there, but the amino group will not be there. So that's why. So depending on the chemistry, N1 substituted, N4 substituted, both N1 plus N4 and non-anilino. Clinical classification. So those sulfators which are used for their antibacterial sulfators. So these are sulfocetamide, sulfadiazine, sulfadimidine, sulfamethoxazole. Oral hypoglycemic drugs. Oral hypoglycemic sulfators like tolbutamide and all that. So वो अलग से is another chapter. Orally, then anticonvulsant is also there. Diuretics are also there. Diuretic sulfators like furosemide, chlorthalidone, butamate, bumetanide, furosemide, torsemide, chlorthalidone. So I have revised your classification. So in the we have seen in the last section that sulfonamides, okay, they was discovered in the 1930 when it was observed that there is one dye known as a prontosilate. This dye, this is the structure of this prontosilate. Prontosilate का structure है यहाँ पर. This dye was used to treat the various kind of infection, and later it was observed that this dye is broken down in the body. इसका metabolism होता है body में, ये prontosil dye का, and you will get a two different molecule. First one is a sulfanilamide, and the first one is sulfanilamide, and another is a triamino benzene or diamino aniline. The antibacterial effect of this protonsil red is because of this sulfanilamide, and after this observation, there was a synthesis of different synthetic sulfonamides. So these sulfonamides, they are numbered according to this. So this nitrogen of sulfamido group is numbered as 1. After that, 2 nitrogen of amino group is known as a. There is one more drug known as a dapsone, which is also sulfonamide derivative, but that drug is used in the leprosy. Drug, dapsone. So dimethyl, 4,4-dimethyl. Okay. So 4,4-diamino diphenyl sulfone. 4,4-diamino diphenyl sulfone. Diphenyl. 4-diamino diphenyl sulfone. That is a dapsone. Structure of dapsone, which is anti-leprotic drug used in the leprosy. Now we'll see the structure activity relationship of your sulfa drugs. SAR of your sulfa drug. SAR of sulfa drug. Structure activity relationship. Only few points are there. Sulfanilamide skeleton is very important for the activity. So if there is no sulfanilamide skeleton in the sulfonamides, then it will be inactive. Sulfanilamide skeleton is very important for activity, and sulfur should be directly linked with the benzene ring. ठीक है, तो आप देखो बाकी सभी जो सल्फर ड्रग रहेंगे उसमें ये सल्फर जो है SO2NH ग्रुप वो डायरेक्टली अटैच्ड टू बेंजीन रिंग. Sulfanilamide skeleton is important. Sulfur should be directly attached to benzene ring. In N1 substituted sulfur drugs, depending upon the substitution on amido group. So in the N1 substituted sulfur drugs, okay, N1 substituted मतलब का आप रहेगा. In the N1 substituted sulfur drugs, depending upon the subsequent amido group, electron donating groups. यहाँ पे अगर उसके बाद में अमाइनो ग्रुप के बाद में कोई इलेक्ट्रॉन डोनेटिंग ग्रुप है, so if there is a substitution of amido group with electron donating group, which will increase the activity. So electron donating group and SO2 group, that will be activity will be increased. Amongst them also, if there is a heterocyclic ring, then it will give you potent derivative. So to electron donating groups अगर हैं जैसे आपका electron rich group होता है, that will increase the activity, and particularly if that is present in the heterocyclic ring, see it will give you potent derivative. Single benzene ring at N1 is more toxic than heterocyclic analog. तो इसके यहाँ पे बाद में कोई अगर cyclic ring है, simple benzene है, that will be more toxic, and if it is heterocycle then it is okay. Okay. So in the say N1 sulfate drugs, depending upon the subsequent substitution at amide group, electron donating group will increase the activity. If that heterocyclic substitution is present, it will give you potent derivative, and if single benzene is there, so it is a toxic in nature. Three amino groups should be present at a para position. So three amino groups should be present at a para position. ये group है आपका. Three amino groups should be present at a para position. Now, if that amino group is present at ortho or meta, if that amino group is present on ortho position or meta position, it will have no antibacterial activity. It's ineffective. So, amino group should be at a para position, and pre-amino group is a very important for activity. Now, substitution on this amino group, if any is there, so that is an inactive compound. It may be active, but the compound should be broken down in the body. अगर इसके ऊपर substitution किया है NH2 के ऊपर amino group के, that will give you prodrugs. Pre-amino group should be at a para position, and it should be free. And substitution result in the inactive derivative or inactive prodrugs. Now, active form of sulfur drug is, that is ionized form of sulfur drug is only active, and maximum activity of sulfur drug is seen in the particular pKa range, that is 6.6 to 7.4. Question आ चुका है. Active form of sulfur drug is ionized form. Okay, active form is a ionized form, and maximum activity is seen in the pKa range value, that is 6.6 to 7.4. Substitution on benzene ring gives inactive compound. Any substitution on this benzene ring, यहाँ पे जो benzene ring है उसके ऊपर कोई आपने मार्कर करने की कोशिश की, so that will be inactive. Substitution on benzene ring will give you inactive compound. Substitution of SO2NH. So instead of SO2NH, if you add SO3H, that is sulfonic acid. Substitution of sulfonic acid और सल्फामेडो ग्रुप. तो ये SO2NH ग्रुप जो है सल्फामेडो, उसकी जगह पे आपने SO3H सल्फोनिक एसिड किया, that will destroy the antibacterial activity. But if you replace this SO3H by SO2H, that is sulfonic acid. If you replace sulfonic acid with the sulfonic acid, then there will be activity will be retained. Normally ये बेंजीन के ऊपर कुछ एडिशन नहीं होना चाहिए, एंड वो जो सल्फामेडो ग्रुप है आपका, उसको अगर सल्फोनिक एसिड डाल दिया आपने instead of sulfomedo group, SO2NH group, so if you replace this SO2NH group by this SO3H, that is sulfonic acid, so that will destroy the antibacterial activity of compound. And if you replace that with the SO2H group, that is sulfonic acid, acetylation at N4 position. तो ये यहाँ पे sulfonic acid, यहाँ पे acetylation करेंगे, that will again retain the activity. Now sulfonamides binds to the basic centers of bacterial. So basic centers like arginine, histidine, lysine, these are the amino acids of the protein. By binding a group like alkyl, alkoxy halides, protein binding affect the pharmacokinetics as well as pharmacodynamic properties of drug. We have seen in the pharmacology कि सल्फर ड्रग जो है प्रोटीन को बाउंड करते हैं, लेकिन कैसे बाउंड करते हैं, कहाँ पे बाउंड करते हैं. Sulfonamides, they binds to the basic centers present in the protein. What are the basic centers? So arginine, the basic amino acid. Histidine is a basic, lysine, and they binds via groups like alkyl group, alkoxy group, halide. Protein binding may affect the kinetics as well as dynamics of this sulfur. Antibacterial activity and pharmacokinetics are dependent on the lipid solubility of these sulfur drugs. Increased lipid solubility of sulfur drug will increase the half-life and antibacterial activity. These are the different important points from structural activity relationship of sulfur drugs. Now you can see there is one drug known as sulfasalazine. It's used for the intestinal infection and locally used for irritable bowel syndrome. So it is a structure of sulfasalazine. Is sulfasalazine. You can see over here it is made up of two parts. So this part is one. You can see it is nothing but the salicylic acid, benzene ring, ठीक है, COH group and OH salicylic acid. इसके बाद में ये बाकी का जो स्ट्रक्चर है, it is a structure of sulfapyridine. Structure of sulfapyridine. So sulfasalazine is made up of two molecules. Sulfasalazine is made up of two molecules. Sulfapyridazine and sulfapyridine and salicylic acid. So ये molecule, this molecule is in when it is given in the intestine, it is reduced or it is broken down by azo reductase from bacterial origin. जो है उसके उसमें एक एंजाइम होता है azo reductase. They will reduce this sulfasalazine into two molecules. First there is a amino salicylic acid, 5-amino salicylic acid and sulfapyridazine. Out of that, this 5-amino salicylic acid will have anti-inflammatory activity and this will have antibacterial activity. This is used in the irritable bowel syndrome. Mechanism क्या है we have seen that mechanism. So sulfonamides, they will prevent the formation of folic acid. So dihydroteroate diphosphate or pteridine plus para-amino benzoic acid. So they will be bacteria will synthesize from these two precursors. So precursor क्या है dihydroteroate diphosphate or pteridine and para-amino benzoic acid. Bacteria will utilize these two from the environment or from the media and will convert into dihydroteroic acid and then it will convert into later dihydrofolic acid. So by enzyme dihydroteroate synthetase or folic acid synthetase. That's this step is inhibited by sulfonamides. क्या करेंगे dihydroteroate synthetase ये जो step है because sulfonamides they have structural resemblance to PABA. PABA जो है para-amino butyric acid and sulfonamide उनका structure same होता है. So instead of PABA, bacteria utilizes the sulfonamides and that's why they make false folic acid. They make a folic acid which is useless to them and that's why bacteria dies. Then again dihydrofolic acid then again converted into tetrahydrofolic acid by enzyme dihydrofolate reductase. This step is inhibited by trimethoprim. Now you can see over here this dihydrofolate is reduced to tetrahydrofolate by dihydrofolate reductase. Okay, ये second role है. During this there is a conversion of NADPH to NADP and this reaction is very important for one carbon atom chain reaction in metabolism. Now structure of sulfur drugs, different sulfur drugs. First one is nothing but the sulfaclomide. You can see easily structure बहुत simple होता है sulfaclomide. SO2NH ये तो common रहेगा. This structure will be common in the all sulfonamides. What will be different? तो in case of sulfaclomide में क्या होगा? क्लो है मतलब क्लोरीन तो आएगा उसमें. sulfaclomide. So यहाँ पे देखो. So it is a pyridazine ring, basic pyridazine ring. So 1,3 nitrogen, 4 dimethyl 5-chloropyridazine. So N1 into 2,4-dimethyl 5-chloropyridazine sulfonamide. That is the IUPAC name of this sulfaclomide. Simple IUPAC name really. And second drug is nothing but the sulfapyridine. So ये structure तो कौन होगा sulfanilamide का. N1 pyridazine, N1 pyridine sulfonilamide. So it is toxic drug and it is no more used. Next one is a sulfathiazole. So thiazole means what? So N1 sulfathiazole. N1 में ये substance sulfathiazole. Sulfur 1, nitrogen 3, thiazole. So 5-membered ring with sulfur and nitrogen. Then next one is sulfacetamide. So acetamide. You can see acetamide. So sulfonilamide will be common. This is the acetamido group. NHCOOCH3. Acetamido group. So sulfacetamide. It is used for the topical eye infection. Now next one is the sulfadiazine. Di मतलब क्या? Di means two. Azine मतलब क्या? Nitrogen. Diazine. So sulfadiazine means pyridazine ring. Pyridine and pyrazine ring, not pyridazine. Pyrazine ring. So sulfanilamide is common and pyridazine is. N1 pyridazine sulfanilamide. That is sulfadiazine used in the meningitis. Nowadays not no more use. Next is sulfadimidine. sulfadimidine. D मतलब क्या है? di मतलब क्या है? 2. मीडियन मतलब क्या है? मी मतलब डाइमिथाइल ग्रुप रहेगा इसमें. डाइमिथाइल पायराजीन. डाइमिथाइल पायराजीन. pyrazine. Dimethyl pyrazine. You can see 1, 4, 5, 6. 4, 6 dimethyl pyrazine. N1 into 4, 6 dimethyl pyrazine 2-il. That is nothing but the sulfadimidine. Sulfatol is used for the GIT infection. Sulfatol is used for the GIT infection locally. So first one is a sulfaguanidine. So sulfaguanidine मतलब यहाँ guanidine group होगा. guanidine. NH NH NH2 is a guanidine. So sulfaguanidine. बाकी सब isotogenes का. Next one is a succinyl sulfathiazole. Succinyl sulfathiazole. Succinyl sulfathiazole. So they are known as both N1 plus N4 substituted sulfonamides. Normally sulfonamide का skeleton क्या है? इतना है. Normal skeleton of sulfonamide. Now this is known as N1 पे क्या है यहाँ पे? Thiazole. N1 thiazole 2-il. N4 पे ऊपर क्या है? Succinic acid. This is the succinic acid. So succinyl sulfathiazole. Thionyl sulfathiazole same. N4 पे क्या है? Thiolic acid. And N1 पे क्या है? Thiazole. Succinyl sulfathiazole, thionyl sulfathiazole. Both these are the prodrug. ये जो है N4 substitution with the thiolic acid or succinic acid that will be broken down inside the body. यहाँ से ये molecule break होगा, ये भी यहाँ से break होगा. It will release this active moiety. Antibacterial effect is due to this moiety. ये antibacterial है. ये सब that will change only pharmacokinetic. Then sulfur. Okay. Next class is nothing but the short acting sulfatals. Short acting sulfatals. First होता है sulfamethisole. So methisole मतलब thiadiazole. Thiadiazole. 5-member ring plus 2 nitrogen. Thiadiazole. Then sulfasomidine. Sulfasomidine. In that dimethyl pyrazine. Dimethyl pyrazine 6-il. Sulfasomidine. बाद में sulfanilamide अपना. सल्फिक्स यहाँ पे देखो नाम में ही देखा इसका ऑक्साजोल. यहाँ पे N1 में क्या है? ऑक्साजोल रिंग है. सल्फिक्स ऑक्साजोल. तो यहाँ पे ऑक्साजोल नाम है. नाउ नेक्स्ट वन इज नथिंग बट द इंटरमीडिएट एक्टिंग सल्फाटल. इंटरमीडिएट एक्टिंग. तो इसमें तो सल्फासोमिजोल पहला. आइसोथायाजोल देखिए. नॉर्मली थायाजोल में क्या होता है? S1 यहाँ पे रहेगा. दैट इज थायाजोल. नाइट्रोजन यहाँ पे तो आइसोथायाजोल. सल्फामिथाक्साजोल कैन सी ऑक्साजोल. नाइट्रोजन प्लस ऑक्साजोल. सल्फामिथोक्सा. यहाँ पे इसमें नाम में ऑक्साजोल. यहाँ पे क्या रहेगा? ऑक्साजोल रहेगा. लॉन्ग एक्टिंग सल्फाटल्स. इन दैट यू आर सल्फामिथोक्सी पायरिडाइजिन. सल्फामिथोक्सी पायरिडाइजिन. यहाँ पे पायरिडाइजिन मिथोक्सी पायरिडाइजिन. मिथोक्सी दो नाइट्रोजन पायरिडाइजिन. देन सल्फामिथोक्सी sulfadimethoxine. यहाँ पे सिर्फ डाइमिथोक्सिल. ओके कुछ नहीं. देन नेक्स्ट वन इज सल्फामिथोक्सी डाइएसिन. बस यहाँ पे सब्स्टिट्यूशन सिर्फ एक ही जगह पे. सल्फाफिनाजोल. तो इसमें N1 में क्या रहेगा? एजोल इमिडाजोल प्लस बेंजीन रिंग. फिनाइल रिंग एंड दिस एजोल. तो सल्फाफिनाजोल. अल्ट्रा लॉन्ग एक्टिंग सल्फोनामाइड्स. सल्फेलिन एंड सल्फामेथोक्सिन. स्ट्रक्चर उतना इंपॉर्टेंट नहीं है उसका. नहीं किया तो चलिए कोई जस्ट मानो. सल्फासेलेजिन इज लॉन्ग एक्टिंग. सल्फासेलेजिन. तो यहाँ पे देखो ये सैलिसिलिक एसिड रहेगा. सल्फामेथोक्साजोल प्लस ट्राइमेथोक्सिन. कॉम्बिनेशन ऑफ सल्फामेथोक्साजोल प्लस ट्राइमेथोक्सिन. So they are combined together. You will get a cotrimoxazole. So combination of sulfamethoxazole plus trimethoprim in a concentration of 5:1. In a concentration of 5:1. You can say 300 mg sulfamethoxazole, 80 mg trimethoprim, known as a cotrimoxazole. They will block sequentially synthesis of folic acid. Now IPAC name है इसका, लेकिन ये simple होता है. आपको ये फिर से बोल लेना पड़ेगा. So we will see the fluoroquinones. So it is a general structure for fluoroquinones. Not a fluoroquinones, it is a standard structure for quinolone antibodies. So this one is known as a naphthapine ring. Okay. So one मतलब ketone. Quinoline ring plus ketone. So quinolone. So this nitrogen is numbered as 1, so that 2, 3, 4, 4 position पे क्या है कीटोन है, 3 position पे क्या है कार्बोक्सिलिक फंक्शन है. ओके, देन 5 यहाँ पे कोई सब्स्टिट्यूशन रहेगा 5 पे, यहाँ पे मोस्टली हाइलाइट्स होता है क्लोरीन क्लोरीन हो गए 7 and 8. This is the numbering general structure for fluorochem. We'll see the structural activity relationship of that quinolone antimatter. So first, at nitrogen 1 at N1 optimum substitution are ethyl butyl cyclopropyl difluorophenyl with fluorine atom if it is present in the cyclopropyl or QU improved activity against the gram. तो N1 जो नाइट्रोजन 1 जो है इसे यहाँ पे दिखा है नाइट्रोजन के ऊपर क्या है साइक्लोप्रोपाइल है यहाँ पे क्या है साइक्लोप्रोपाइल. सो N1 ऑप्टिमम सब्स्टिट्यूशंस आर नथिंग बट either ethyl butyl cyclopropyl difluorophenyl or if fluorine atom addition in a cyclopropyl or 1-butyl result in the improved activity against the laminate. At carbon number 2, okay, so there should not be substitution like methyl hydroxyl or other group. So at C2 there should not be substitution. If you substitute at carbon number 2, it will give you no activity. Both N1 plus C2 will possess notable activity. मतलब अगर N1 पे भी है substitution और कुछ C2 में भी किया है जैसे यहाँ पे, so it will have limited activity. Possess notable activity. Modification of carboxyl function at C3 that can cause decrease in the activity. Replacement of carboxylic group with isothiazole group give more active isothiazoloquinolones. Due to aromatic characters and acidic product of nitrogen, other groups like sulfuric acid, phosphoric acid, tetrazole or esterification will result in the loss of activity. तो यह carboxylic जो function है carboxylic function C3, so can cause modification of carboxylic function at C3 decreases the activity. But if you replace carboxylic group with isothiazole group gives isothiazoloquinolones like this. It is isothiazoloquinolones. So it is a more active than normal fluoroquinolones because of the and due to acidic proton of nitrogen. And anything or other groups like sulfuric acid, phosphoric acid, tetrazole or esterification of this carboxylic acid will lose the activity. Now C4 oxo group, C4 oxo group, C4 ketone group. C4 oxo group of quinolone is essential for activity. Replacement of that ketone with the 4-thioxo or sulfonyl group leads to loss of activity. तो ये जो का 4 number का जो ketone group है is very important for activity. If you replace this with 4-thioxo or sulfonyl group, that will lose the activity. Okay. Now next one is add carbon number 5. If you incorporate or if you other substitution like amino, methyl, chlorine, hydroxyl, sulfhydryl or ether groups. At C5 incorporation is useful, so that compound is useful. C carbon number 5 के ऊपर आप ये ऐड कर सकते हो जैसे NH2, CH2, chlorine, OH, SH, SR. So NH2 is more active than CH3, then chlorine, hydroxyl or sulfhydryl or thiol. At C7, piperazine moiety is very important for activity. And other aminopyrrolidins, they are also active like this. ये normal piperazine हो गया आपका. So if you another analog like this pyrazole analog or this methyl piperazine analog or this again pyrrole analog, they are also active. Add carbon number 8, chlorine will give you more potency against the gram-negative bacteria. So at C8, chlorine atom offers good potency against the gram-negative bacteria. Methoxy group gives against the gram-positive bacteria. तो अगर कार्बन नंबर 8 के ऊपर जैसे ये हो गया आपका ये 1, 2, 3, 4, 5, 6, 7. So at this chlorine atom provides the activity against the gram-negative. Methoxy group again positive. Order of activity is nothing but the chlorine, methoxy is greater than hydrogen and trifluoromethyl, then methyl vinyl. Now halogen, chlorine or chlorine at C8 improves the oral absorption of compound that affect the kinetics. Linking of N1 group to a C8 position will give you oxygen ring leads to O-phlogism. Linking of ये जो कार्बन है, कार्बन नंबर 8, this group linking of this group with the nitrogen 1, that will give oxygen ring, leads to another active molecule known as O-phloxin. लिंकिंग भी एक्टिव ही रहता है। नॉर्मली बाकी फ्लोरोकिनेस में यहाँ पे ऐसा कुछ नहीं मिलेगा आपको, ये लिंक नहीं रहेगा। दिस लिंक इज प्रेजेंट ओनली O-phloxin, oxygen ring, nitrogen plus oxygen in 6-membered heterocyclic ring known as oxygen. And levofloxacin is a isomer of this O-phloxacin. O-phloxacin is supplemented as a racemic mixture. ये O-phloxacin जो होता है वो racemic mixture होता है, उसके बाद में उससे levofloxacin, levo isomer isolate किया, and that has given name levofloxacin. That is more active than O-phloxacin. So we'll see individual drugs. Fluoroquinolone, nitrofurantoin जो देखा है अपने फार्माकोलॉजी का, they will have structure like this: furan plus nitrofurantoin, nitro group plus this furan, pyrazolidine, nitrofurantoin. Okay, so those molecules. Nitrofurantoin is used as a urinary antiseptic. Pyrazolidine is used as a intestinal antiseptic. Okay. Nalidixic acid is the first member of fluoroquinones. So nalidixic acid, यहाँ पे देखो nalidixic acid. Now general structure of fluoroquinones 1, 2, 3, 4, 1 and 8. Initially, there was a synthesis of some analogs like oxolinic acid, phenoxyacin, then rosoxacin, but they were not much helpful. They was having activity but having more side effects. So after that, norfloxacin was synthesized. Norfloxacin. यहाँ पे देखो, यहाँ पे 6 पोजीशन पे क्या है, फ्लोरीन एटम है, 7 पे क्या है, पिप्रेजिन रिंग है, फ्लोरीन पिप्रेजिन, यहाँ पे इथाइल ग्रुप है, इनवन इथाइल, बाकी नॉर्मल स्ट्रक्चर है, एल्डिहाइड एसिड, नॉरफ्लोक्सिन। सिप्रोफ्लोक्सिन में क्या किया, ये सिर्फ इथाइल जो ग्रुप है, दिस इथाइल ग्रुप फ्रॉम नॉरफ्लोक्सिन was converted to cyclopropyl group, cyclopropyl, C for cyclopropyl, C for cyclopropyl. Norfloxacin का जो इथाइल ग्रुप है, N1 इथाइल, that is converted to cyclopropyl, and you will get a ciprofloxacin. बाकी स्ट्रक्चर तो सेम ही है, बस उतना ही डिफरेंस है. You can see over here, ये डिफरेंस है. It is a norfloxacin, it improved activity. Now next one is sparfloxacin. तो sparfloxacin में क्या है, जो पिपराजिन रिंग है उसमें डाइमिथाइल ग्रुप. सिप्रोफ्लोक्सिन का स्ट्रक्चर एज इट इज निकल हुआ, इसमें सिर्फ ये ऐड करो, क्या 3 and 5 dimethyl piperazine. Okay, at 7th position, so only instead of simple piperazine you have dimethyl piperazine, that's it. बाकी और एक फ्लोरीन एटम ऐड किया है यहाँ पे, कार्बन नंबर 8 के ऊपर, बस इतना ही डिफरेंस है, बाकी सब कुछ सेम है. लाइक सिप्रोफ्लोक्सिन, we get a new molecule sparfloxacin. In gatifloxacin, same structure of ciprofloxacin, just two difference. Again, कौन सा difference है? Instead of dimethyl piperazine, here we have only 1 methyl piperazine or only monomethyl piperazine, 3 methyl piperazine plus 8 methoxy group. That's it. Rest of the structure is same like ciprofloxacin. And pafloxacin, again सेम स्ट्रक्चर लाइक नॉरफ्लोक्सिन. ये जो स्ट्रक्चर है नॉरफ्लोक्सिन का स्ट्रक्चर है, कौन सा इतना स्ट्रक्चर नॉरफ्लोक्सिन का है, बस एडिशनल क्या है, पिप्राजिन के ऊपर एन मिथाइल पिप्राजिन, बस इतना ही ऐड है, बाकी सबसे मेन लाइक नॉरफ्लोक्सिन. इन लोमीफ्लोक्सिन, लोमीफ्लोक्सिन भी जो आपका नॉरफ्लोक्सिन है उसका स्ट्रक्चर निकालने का आपको यही ऐड है, एक मिथाइल ऐड है और एक फ्लोरीन ऐड. एडिशनल क्या है उस स्ट्रक्चर में ये मालूम होना चाहिए, बाकी तो बेसिक स्ट्रक्चर किसके जैसा है, से pafloxacin and lumeproxacin, both are the structure having similar with the norfloxacin, and both sparfloxacin and gatifloxacin will have structure similar to ciprofloxacin. तो सिप्रो में क्या है, सिप्रो बोले तो साइक्लोप्रोपाइल, सिप्रो, स्पार एंड गैटी, बोथ मोस्ट ऑफ साइक्लो.